This lesson is going to explain the different angle relationships. And the first one that we're going to talk about are vertical angles. And vertical angles are opposite of each other when you're looking at an intersection of two lines. And vertical angles are always equal. So if you look at the diagram I have drawn here, examples of vertical angles would be angles 1 and 3, and also angles 2 and 4. And like I said, these are equal, so they're going to have the same value. And adjacent angles are, like the name implies, adjacent to each other, so that means they're next to each other when we're looking at an intersection of two lines, but these are not equal. And so if we look for adjacent angles in our diagram, if we identify all of them, we can say 1 and 2 are adjacent angles, and then we also have 2 and 3 are adjacent, 3 and 4, and then 4 and 1. These would all be examples of adjacent angles. And then a complementary angle are two angles that sum to 90 degrees, so they form a right angle when they're put together. And then a supplementary angle is two angles that sum to 180 degrees. So 90 degrees would be like if we have a right angle and we have a line that bisects them. So we have angle A here, and then we have angle B here. A plus B is equal to 90 degrees. And then 180 degrees we know is just on a straight line. So if we have a straight line, we have a line coming off, we have angle A here and angle B here, we're going to have A plus B is equal to 180 degrees, and that's a supplementary angle. And so the next thing that we're going to talk about is corresponding angles, and corresponding angles come into play when you have a transversal that cuts other lines. They don't necessarily have to be parallel, but in most cases we draw them as parallel. So if we look at our diagram, we have two parallel lines cut by a transversal, and corresponding angles will be the angles that are at the same location at each intersection, and these angles are equal. So we see that we have the two different intersections, the one on the upper line, which contains 1, 2, 3, and 4, and the intersection at the lower line, which has 5, 6, 7, 8. So the angles that are at the same locations at these two intersections are going to be our equal corresponding angles. So examples of these would be 1 and 5, because they're in the same spot at each intersection. And then we also have 2 and 6, and then 4 and 8, and finally 3 and 7. All of these are in the exact same location when we compare the top intersection to the bottom intersection. And now if we look at an example, we're going to identify all of the angles present when we're only given the first angle, which is 72 degrees. So the first thing that we can see is, well, angle 1 and 72, well, I guess a different way that we could do it, we could say the 72 degrees and angle 2 are vertical angles. So we know they're going to be equal. So we can come down to our list over here, and we know angle 72, or angle number 2 is going to be 72 degrees because it's opposite of our given 72. And there are multiple ways you could start this. You could have Another thing you could have done was said, well, angle 1 and angle 72 are supplementary, and find angle 1 that way. There's multiple ways you can go with this, but this is just one. And so the next thing that I will do in this one will say is 72 and angle 1 are supplementary. And so we will say, in order to find that, we'll say 180 degrees minus 72 equals angle 1. And this gives us a value of 108 degrees. So I'll go fill this in on my little list over here. So now we know angle 1 and 2. And then the next thing that we can say is angle 1 and 3 are again vertical angles because they're opposite the intersection. So we know these are equal. So we can go in on our chart and fill in angle 3 is also 108 degrees. And then now from here we have the whole top intersection, so we're going to do the bottom intersection, and we're going to use corresponding angles to find 4, 5, 6, and 7. And so we know angle 4 is equal to our 72 degrees because it's equal to that same position on our top intersection. We know angle 5 is equal to angle 1, which is equal to 108, what we found earlier. And then angle 6 is in the same position as angle 2, and angle 2 is 72 degrees. And finally, angle 7 is the same as angle 3, and angle 3 is 108 degrees. So that is how you would use angle relationships to find all of the given angles with lines and transversals.